Yeah. Oh, just before Sarah comes on, I want to say that Sarah, this is not the first time that she's spoken at our conference. And previous years, she was a student, and I remember being really impressed with her presentation on it was VTEM data in the Fort McMurray area. So now she's joined after completing her PhD. She joined Condor Consulting North, and so we're very pleased to have her here. And this paper was presented at the SCG. I think your paper was within I think top 5, was in the top 5 of the best papers in the mining session. So I invited Sarah to present here today.
Great, thank you. So continuing on the gold trend, it's nice of John to present the board and talk there. So my talk today is lessons from the past, exploring for Abitibi greenstone-hosted deposits using geophysics, and I'll look at actually 3 case histories, but I'm going to try and make some references to what Jean presented too, because it fits right in. So first of all, let's imagine you're an explorer, which is pretty easy to do because we all are, and especially in the Abitibi greenstone belt. It's not an easy task. The geophysical responses, as we'll see, will vary between different camps and different styles of deposits. But within the Abitibi greenstone belt, we'll see that we're going to focus on structural settings, the host geology, as well as regional attributes. So today what I'm going to do is show 2 case histories that are really quite well known, and then apply that knowledge to a third, which is just a prospect at this point. So this there's the Abitibi greenstone belt, where we're here. It's a volcano sedimentary belt within the Archean Superior Craton. It lies, stretches on the Ontario and Quebec border, about 700 kilometers east-west and 200 kilometers north-south. And this area contains 14 different mining districts with over more than 50 gold deposits and also 80 VTEM deposits. And all of these deposits, as we'll see in the next slide, they lie along major deformation zones, and this is really key to this area. And some of the gold camps here that you might be familiar with: Timmins, Crooked Lake, Malartic, Val-d'Or. So here's a regional geologic map. So first of all, the red shows the major deformation zones. So as you see, they all run pretty much east-west, very parallel to one another as well. And then between there, we've got the green, which are mainly volcanic rocks. We've got granitic rocks surrounding there. And then all the little yellow triangles, especially down here, those are all different deposits, mine camps. So what you should off the bat see is that there's a really good correlation between deformation zones and deposits. And that's the first clue to how we're going to explore. So in more detail, this is what a deposit looks like. We're looking at these greenstone vein belts down here. Like I said, they lie along major deformation zones. They're often spatially and genetically related to faults and shear zones, so we should be looking for anything where there's shear and strain faults and such. The gold mineralization itself lies within quartz and quartz carbonate vein and vein stockwork, and then they're also commonly associated with sulfide and graphite. Now, so let's take that geology and relate it to something I'm a bit more familiar with, geophysics. So for example, we're going to first traditionally start off with regional electromagnetic surveys. So in the olden days, that might be an input data which is flown with a fixed wing aircraft, or like VTEM, we use a helicopter one. Sulfide minerals and graphite are usually good conductors, but this is going to depend on the volume that's present, or if it's disseminated as well, what John had just talked about. Pyrrhotite can be conductive at lower concentrations than pyrite. So there's different minerals that are going to have a different effect on the data. And then so the next step would be also to collect magnetic data, which can either be done airborne, which is collected coincidentally with the EM, or moved to ground surveys once something of interest has been identified. So within the sulfide-bearing rocks, there's going to be a wide range of susceptibility, with pyrite on one end and magnetite on the other end. So we have a wide variety of what we can see in the magnetic data, and this is also going to then be superimposed on whatever rocks there are and what kind of magnetic signature they have. Alteration can also be common, so that's another thing to keep in mind of how that's going to change the magnetic signature. The third method here is BC resistivity and IP. So now we're looking more at ground surveys. So these are useful to help delineate any airborne conductors that were identified. And IP can be more sensitive to lower concentration of sulfides, which produce little EM response, but might be a bit more diagnostic when we look at ground surveys. And then when all is said and done, and you think you might have something, you still got to go and drill a hole into it and hope that there's something there. So there's two types of drilling that are commonly done. Bedrock diamond drilling to obtain core samples, targets, but also just overburden drilling to look at the till samples and do geochemical analysis and look for any dispersion or anything related to how things might spread. This entire area has glacial cover as well, so that makes some more exploring a bit more challenging. So the first deposit I'm going to look at today is Detour Lake, which is up here on the Ontario-Quebec border. Borden would be kind of more over here, down to the southwest. It's produced 1.8 million ounces between 1983 and 1999. And an open pit was started there in 2013 by Detour Gold, about 650,000 ounces per year. And they claim to have about 60 million ounces in reserve still. It lies along the Sunday Lake Deformation Zone. Okay, so this is what the geology looks like a bit more in detail. We've got the Detour Lake mine right here. There's also the West Detour deposit. And also a zone here on the other side of this sediment package. And what we really have here is a sandwich. So we've got mafic and felsic volcanics up here, as well as here, which comprises the Laurel assemblage. We've got this Calpatina assemblage of plastic sediments in the middle. And as you see here, we've got our substructural faults that separate those two. As you mentioned before, there's also dikes that will go through at different orientations usually in this direction. The Laurel assemblage, right here on, if we look closer in on this area here, you see that along this contact is where we see the mineralization, and that lies within the lower Detour Lake deformation, formation. And that contains, it lies along the Sunday Lake Deformation Zone, and it hosts the chirp marker horizon, which is when they look at the drilling, when they see this marker, that's really where the mineralization lies. So they can follow that marker and continue to find where the gold is. So along with this, we see pyrrhotite, chalcopyrite, and pyrite associated with that gold mineralization. So here's the regional magnetics data. Pretty easy to map that towards the geology. There's a bit of a question here, is that was the geology interpreted partly from the magnetics, given that there's some overburden, or is this reflective of this? So there's a bit of a, you have to keep in mind, a bit maybe with a grain of salt whenever we look at some of this data, that the geology might be influenced by geophysics and vice versa. But we've got Detour lying right here on that boundary between the Laurel and the Calpatina. Historically, in 1974, an input airborne EM survey was flown. We've got the lines going this way. That anomaly number 38 is what was flagged as a medium priority, but that was actually the anomaly that was associated with the deposit itself. And that anomaly has a dual peak EM response, kind of what we saw in the last talk. And there's also a coincident magnetic anomaly. So very similar to what John just showed, is that we have an EM conductor as well as a magnetic anomaly. Okay. There's also a DCIP survey done over this area. So two of the ore zones are outlined here in the black lines. What we see is we have a conductive anomaly and chargeability high. So if we now summarize this, first case history, we've got a strong linear conductor with coincident magnetic high, relatively high chargeability, and low resistivity responses over the deposit, as well as an east-west trending structure along a deformation zone. Second case history is Casa Berardi. We're now on the Quebec side of things. This lies along Casa Berardi deprivation zone. This has produced 1.8 million ounces and was owned by Placer Gold. It's now owned by Hecla Mining. And they have about 2.5 million ounces still of proven reserve. They produce about 150,000 ounces of gold a year, and they also have a good amount of silver that comes out. The geology here, this is also a bit different when you look at geology, Ontario versus Quebec. So here we've got, this is the area here, a bit more complex. It's underlain by naked volcanics. You've got intrusive on the north and on the south. And you can see all these dikes cross-cutting the older units as well. It's spatially and genetically associated with the east-trending Casa Berardi fault. And if we now look, this is a regional or airborne magnetic, so those dikes immediately pop up really well. We've got this large regional magnetic high that extends to the east over on this end here. And then the deposit is actually going to lie right on the flank here. Can't really identify it in the airborne magnetics. When we look at more closely at other data sets, we'll see it pop out. This was originally called the Golden Pond deposit because there's two ponds that lie right there. So a clever geologist named it the Golden Pond deposit. And it's known as the mineralization is associated with what's known as the Golden Pond sequence. So it's a package of sediments and volcanics. There's east-west trending sedimentary units, and we have also felsic volcanic flows and pyroclastic occurring as thin, discrete units within that. It's a quartz vein-type gold deposit. We've got pyre and arsenopyre banded veins within this shear zone. And the rocks are also highly silicified, and there's disseminated sulfides within this fractured host rock. So we've got smaller amplitude responses that were masked by the airborne data by that large southern magnetic high. But if we, did that show up? Interesting. It's not supposed to be so faded, but so we've got the two ponds here. So these are some of the EM conductors that were plotted on top of this map, but we're looking at magnetics. So that large magnetic high that you saw in the regional sits here to the south, and then we've got the small magnetic high right here. So that was masked by just the resolution of the airborne. This is the discovery drill hole right here. Okay, good. So now if we look at a profile of this, so here's the mag data. This is that high southern response that we saw down here to the south. And then if we look now at the frequency domain EM, we have an anomaly that sits right here. So, and you can also see that we get a negative in-phase signature in the EM associated with that mag high. So, a nice response there, but because of the proximity of each other, they kind of tend to be a bit overlapped. Oh, well, that's not great. There's no data. So what this slide was supposed to show was EM as well as DC and IP data over here on this line. And what we basically saw, it was just an N1 to 2 survey for the DC resistivity and IP. And we saw, so this was right over here. So over here, over on this end, we had a little bit of a chargeability high, as well as a crossover. So there was a vertical loop EM survey. What we had was a crossover here and a crossover here, basically marking where those boundaries of those geologic units were. Don't take my word for it. Hey, that one showed up. So now we're looking at this line here, and what we can see is a bit of a, so like I mentioned, just N1 and 2 for the DC resistivity survey and IP. We've got these crossovers from the vertical loop EM lining with contacts. And then what we have here is that the mineralization lies right along this edge here. So pretty flat mag anomaly. This is that big feature to the south. And, pretty unclear DC resistivity anomaly, and I think that's just because we're dealing with an overburden and the penetration might not be that deep with just N2. So just a quick overview now, add on to Detour Lake. We've got a moderate linear conductor with an offset linear magnetic high. The DCIP results show a little bit of promise, but I'm hesitant to say that they really penetrate through the overburden and image what's down below from the mineralization. And again, we've got that east-west structure going this way. So our final case history is Destiny. It's just a prospect. It's not being mined. And my question is, can we use the trends of knowledge from previous case histories that we've seen to make a decision about Destiny? Basically, would you pursue it? This is within Quebec now, along the Jacobi Deformation Zone, which goes through here. Right. So this is the regional geology. We've got some intrusives to the north, and Destiny sits right here. So we've got some east-west trending structures. The main deformation zone lies just to the south of it. And this is the regional magnetic survey. So you can see really good correlation between the two, but again, you know, did this influence that, and how much of this is based on outcrops, actual roots on the ground. So we can see our dikes coming quite nicely. This area here matches pretty well over here with the these gabbros that sit along this area. Now zooming in, absolutely useless when the pictures don't show up. So what I had here was my geologic map. It's the same one here, I just focused in. And I'll just tell you that there's a road that goes along here and up to here, and then a parallel that crosses through there. So that's all that was showing. So we've got about 10 to 20 meters of glacial cover, and east-west trending gabbro and diorite sills within those mafic volcanic intrusives. And they've noticed that there's a lot of sheared and altered rocks and quartz vein sections near those mafic sills. And like I mentioned before, cross-cutting dikes. And I guess I can tell here, when Jean Copy opened this PowerPoint, we noticed that there was an error saying some things didn't call properly, so apparently so this is the magnetics. You want to imagine the geology map that used to be there. So like I said, there's a road here and a power line there. So you can see the power line effect on the VTEM magnetic survey there. Not much of a road, but so basically we get these linear magnetic highs associated with gabbro here, here, and then Destiny. So we're looking at this area right here. So this is a cross-cutting diabase dike. This is the EM data. So this is the add tau. So we at Condor calculate our own tau that's based on a moving window. So easy to see where the conductive features are, but now because there's a road and a power line, there's something interesting along the road. That's not a really nice area to go and do a survey in. Now you've got to go interpret this. But we can still see there's something there that has an east-west structure, so a linear conductive feature right along there. Something interesting there too, actually. So now comparing these two together, we've got this linear magnetic high up here. We've got a linear conductive feature. I didn't show them in this talk, but there are, I think, in the paper for SEG. There was also a DCIP ground survey done over this area, but it was pretty inconclusive. So again, not very deeply penetrated. So based on what we've seen at the other two sites, and you can include Borden in that as well, would you pursue here and do a drilling program? So now, good. So this is actually what the resource here is. We've got an estimated resource of 10 million tons at about 1 gram per ton. Not too big, but we've got some mineralization sitting right through here, gold mineralization over here in this zone, and then some over here as well. So this one in particular is the main area. It sits right here with this linear magnetic high. That's where our linear conductor also sits. This area, is going to be completely obliterated by the effect of this road and power line along it. But again, it kind of matches along with the magnetics. So in summary, we've looked at 3 case histories here. Gold exploration in Abitibi is going to remain a pretty difficult task. But I think with each piece of information that we're given, even if we don't hit a direct bullseye, it adds a little bit to our puzzle, and we get a bit more understanding. And I like this quote that I can't across recently, you know, the only real mistake is the one from which we learn nothing. So even if the data doesn't show what we were really hoping for, it's a little bit extra information that we can use to move forward and help us explore and improve this area. With that, I thank you and we'll take any questions.
Sarah, nice talk. I mean, you're showing like a magnetic association, but like we always think of like these gold deposits, the alteration that is mag depletion that follows the. So how do you explain that your example don't have mag, as did mine, but I mean in our case the pure type was just like a marker unit. Is that what you're seeing similar?
From what I've read, and I'm not an expert on this at all, but from what I've read, I think it's maybe more of like a geologic context rather than a sulfide context that gives them that.
I couldn't hear the question, in fact. What was the question?
Well, so the question was that we tend to see alteration and magnetite depletion in these areas. So how do we still get a magnetic eye associated with these deposits? And right? Is that,
yeah, that's right.
So, so like what I said earlier is that we're looking for these structural patterns more than, rather than gold mineralization specifically. But I think too that a lot of times, just because of the geology that we have, there tends to be a bit more magnetic response. So I think it's a case by case.
Go ahead, Jerry.
Yeah, as someone who actually was around when some of those discoveries, those venerable case histories were fresh and new, it's good to see them resurrected and reconsidered. I think, the aspects of geology are considerably more complex than the sort of single kind of category. Each of those deposits has rather, not necessarily unique, but rather special characteristics. Detour, of course, has as much base metals as gold. You run into Laurie Reed at the PDAC, he can tell you all the details there. And Detour River, he started, Casa Berardi was actually pursued originally by INCO for nickel, but they didn't recognize its gold potential.
Right.
And just in general on that issue, the generally accepted model for massive sulfide mineralization is these days related to stratigraphy rather than structure. It changes the geophysical kind of strategy or tactics, but it does frame the overall exploration pursuit in a different fashion.
Ed, do we have any questions? If not, let's thank Sarah for